Hello guys, welcome back to our channel. So again today in this video, Shomo sir would be helping us with some of the questions. So Shomo sir, what questions are we discussing today?
Again, sir, another CAT problem. Very similar to what we did in the last video, a CAT problem based on proportionality, but somewhat interesting than the previous question. So let us jump into it.
Yeah, sure.
So we start with a motorbike leaving point A at 1 p.m. and moving towards point B at a uniform speed, so maintaining a constant speed. A car leaves point B, so the destination of the motorbike here. A car leaves point B at 2 p.m. and move towards A, so the source of the motorbike, right? So it's moving in the opposite direction to the motorbike, of course, at a uniform speed, which is double that of the motorbike. So we have a relationship between the speeds of the motorbike and the car. The car speed being double of the motorbike speed.
Right.
Now, we have a disparity in terms of the starting time. So motorbike starts at 1 p.m., but the car starts at 2 p.m. So we have to, right now when we are comprehending it, we don't have a clue of what role will that disparity play, but we should notice it. We should notice that they are not starting at the same time.
Correct.
Let's continue to read. So they meet at 3:40 p.m. So now this becomes a little easy, because if you think about that disparity actually doesn't matter anymore, because for example, the motorbike starts at 1 p.m. 3:40 p.m. it reaches a certain point along the way. So we know the traveling time from A to that point, right?
Right.
Same with the car, although starts at a different time, but we know the traveling time of the car.
Correct.
So they meet at 3:40 p.m. at a point which is 168 kilometers away from A. Now, who is traveling, or who is rather starting from A? The motorbike, right? So this distance that is given is directly with relation to the motorbike.
Correct.
Now, what is the distance in kilometer between A and B? That is all we have to figure out, right?
Right.
Now, there are a lot of ways to solve this problem. I'll just first draw the diagram out here, and I'll try to simplify the problem as much as we can so that it takes the least amount of effort to solve this problem. So I'm just going to take the two endpoints. So what I mean by two endpoints is one is A, another is B. These are the two endpoints in the perspective, right? One object is traveling from A to B, the other is traveling from B to A. And I'm going to take an arbitrary third point. So I don't know where it is going to be. So I'm just going to arbitrarily place it here or something. And let's say that is some point E or something. So this is A, this is B, and this is some hypothetical meeting point, or let's say M for meeting point. So this is point M. Now we know that the motorbike starts from point A at 1 p.m.
Right.
We don't know the actual speed of the motorbike, but what we know is from A to M, it has covered a distance of 168 kilometers, right?
Right.
We also know that both of these objects reach this point at 3:40 p.m.
Correct.
Now, think about this. If we need, we can actually calculate the speed of the motorbike, right? Because we have the distance, we have the time,
Correct.
We can very well calculate the speed, right? So I'm going to write the speed, but not actually. I'm just going to represent it in a product form or something. I'm just going to not calculate it as of now. So we have the distance as 168 kilometers. This motorbike is starting at 1 p.m. and reaching this point at 3:40. So that is 2 hours and 40 minutes. So that is 120 plus 40, 160 minutes. But that is in minutes. So let's convert that to hours, or let us leave this as 168 by 160 kilometer per minute or something. I mean, we always don't have to take kilometer per hour, right? So let us leave the speed as 168 by 160 kilometer per minute. Acceptable?
Correct.
Okay, fair enough. Now, what about the car now? So the car we know starts from here at 2 p.m., right?
Right.
Also reaches 3:40. Also reaches this point M at 3:40 p.m. because they're meeting at point at this arbitrary point, right? So the car has actually covered this distance in 1 hour and 40 minutes. So that is 100 minutes.
Right.
But what we know is the car speed is double of the motorbike speed. So the car speed should be twice of this 168 by 160.
Correct.
So this is the speed of the car. This entirety is the speed of the car multiplied to the time. So this is the advantage. I don't have to convert this to hours again. So we have kilometer per minute, right? So this thing is kilometer per minute into minutes should be kilometers, right? So this thing should be the kilometers, or the distance from M to B.
Oh, nice.
Isn't it? So all we have to calculate this, because what we're looking for is the distance between A and B, because 168 plus this will be our answer, right? So let us simplify
Correct.
this. So if you notice, I mean, this 160 is 8 into 20, 100 is 5 into 20. So this goes off, 5 remains. This is 8. And then we have 21 here. So 21 and 2 into 5 is 10. So this is 210 kilometers.
Right.
So we have 210 here, 168 here. Just add it up. We get 378 as an answer.
Pretty simple.
Pretty simple. So all you have to do, I mean, this is what I've explained in the very first video, right? I mean, in any QA problem, the 3 steps are comprehension, process, and calculation. So if you comprehend it properly, you know, what do I mean by comprehension? Comprehension is obviously focusing on the objective. So in this particular question, we're looking for the distance. Kept the objective in mind. What are the relevant information? So the relevant information from this context was the distance between A and M, the time of travel for the motorbike. We can figure out the speed. From the speed of the motorbike, I can figure out the speed of the car. And from the speed of the car, because I know the traveling time of the car, I can figure out the distance. So the process, the mind map automatically happens, right? If you are focusing on the relevant information, keeping the objective in mind. So we can get the answer as simply as possible.
Right. Pretty simple, guys. Again, wonderful cat question. Thanks a lot, Shomu sir, for this pretty simple solution.
Yeah, thank you, Ashar.
Thanks a lot, guys. Thanks for joining in. Have a nice day.
If you haven't yet checked the full playlist containing this video, then check the description for the direct link. Also, if you enjoyed this video and want to stay updated with our daily questions, tutorials, and problem-solving sessions, make sure to hit that subscribe button and the bell icon to never miss an update. In addition to our daily questions, we also offer comprehensive preparation for CAT and other management entrance tests. If you're looking to excel in these exams, we highly recommend checking out these courses in our website. To get a taste of what our courses have to offer, we invite you to take a free demo. The demo will give you a glimpse into the quality and effectiveness of our teaching methods, study materials, and practice resources. You can find the relevant links in the description of this video. Have a nice and successful preparation ahead. See you in the next one.